Did you know that every time you send a message or make an online purchase, thousands of lines of unbreakable code are working behind the scenes?
Welcome to the world of encryption, where your data remains safe from prying eyes.
In this video, we'll uncover various encryption algorithms, starting with TLS, or Transport Layer Security.
This protocol is the backbone of secure internet communications, ensuring that your online interactions remain confidential.
So, what exactly is TLS?
It's a cryptographic protocol that encrypts data between two communicating applications, such as your web browser and the server you're connecting to.
This is how your personal info stays safe while shopping online. But TLS isn't infallible. There are vulnerabilities that can be exploited, like the infamous heartbleed bug.
This serves as a reminder to stay updated on the latest security practices.
Let's dive deeper into potential threats to understand the landscape better. Have you ever wondered how platforms like WhatsApp keep your messages secure? The answer lies in end-to-end encryption, E2E. With E2E, only the sender and receiver can read the messages, even the service provider cannot access the content. Let's break it down. E2E uses public and private keys for encrypting messages.
When you send a message, it's encrypted with the receiver's public key and can only be decrypted with their private key.
Pretty cool, right?
If you're finding this information useful, don't forget to like the video and subscribe for more insightful content like this. Your support helps us create more engaging videos on important topics.
Now, let's take a leap into the future with homomorphic encryption, an exciting advancement that allows computations to be performed on encrypted data without ever having to decrypt it. This means that your data remains safe even while it's being processed.
Imagine sending your health data to researchers, but without them ever seeing your actual information.
That's the power of homomorphic encryption. It's a game changer for data privacy, especially in healthcare and finance.
Here's a surprising fact: while traditional encryption methods rely on the complexity of decoding, homomorphic encryption is based on mathematics that can make it useful in cloud computing and beyond.
The possibilities are endless.
As we wrap up, let's recap. We've explored TLS, the critical importance of end-to-end encryption, and the groundbreaking potential of homomorphic encryption. Each of these technologies plays a vital role in securing our digital lives.
What does the future hold for encryption? Will we see perfected methods that can withstand quantum computing attacks?
Stay tuned for our next video, where we'll explore the latest trends in encryption technology.
Don't forget to subscribe.